All right, guys, welcome back. We're looking at the answers to the practice from 16.2 today. We're going to look at questions 10 through 17. I'm just going to kind of walk you through the answers. Hopefully you had as much fun working them as I did. Okay, number 10, the question asks, Jamie says a quadrilateral with one right angle is a rectangle. Find a counterexample to show that Jamie is correct, or incorrect, I apologize. The issue here, right, is that Jamie says a quadrilateral, and we know that the rule is a parallelogram, okay? So all they're looking for is a counterexample, so I've drawn one, right? Your drawing might not look like mine. As long as it has four sides and one right angle and it is not a rectangle, you win. Congratulations. Number 11, it says, do the diagonals of a rectangle bisect each other? Justify your answer. Remember, bisecting diagonals is a parallelogram property, and all rectangles are parallelograms. Therefore, yes, they do. Number 12, 13, and 14 are all very similar. And so for all three of them, I've kind of rough sketched a graph up here. You can do the same thing. It doesn't have to be perfect. You're just rough sketching the graph. Number 12, the points they give us work out really nice because they're kind of lined up. These are the 3 points they give us. So we kind of get this line here. And then we can see that, oh, our fourth point is going to be up here. Turns out that it's 3, 2. That one's pretty straightforward. When you get to 13 and 14, there's a little more work to do, a little more noticing, if you will, as far as to find the answer. And so I kind of wanted to walk you through what I did there and some things to avoid or some things to be careful with. So what I've done for number 13 is I've graphed the 3 points they've given me, and then I'm looking at where would that fourth point be. Here's where the mistake you could make. If you try to go from this point to this point and then down, right? So let's say we draw this angle here and then we draw a line here. That's tighter than a 90. That's not going to be a rectangle. If I do this, that's going to give me a parallelogram, and that is not what I want, okay? I'm looking for a rectangle. So it means I have to go up here, all right? So what do I do? Well, it's still a parallelogram. Rectangle, yes, but also a parallelogram. Therefore, this slope has to stay the same over here. So what I do is I find my slope here. My x value is going down by 6. I went to the left 6, but I went up 8. So I'm going to go to the left 6 and up 8 over here. So I'm going to use that formula. I'm going to do 4 minus 6, because I'm going to go to the left 6. And then I'm going to go up 8, so I'm going to have 2 plus 8. So the coordinates I'm looking for, 4 minus 6, I'm going to get negative 2, comma 10, because 2 plus 8 is 10. And so that's where my fourth point is going to be, is somewhere way up there, okay? And that's going to make my rectangle. Cut a little bit off my board, but you get the idea, and hopefully you can see that. 14, exact same idea. Again, if you try to draw the line in a different order, you're not going to have a right angle, okay? And my graph's not perfect, but I guarantee it's better than the other one. If you want to check to make sure you're doing it correctly, check your slopes. Find your slope right here, find your slope right here, make sure that it's a negative reciprocal of itself, okay? So using the same idea I did there, in order to get from 6 to 4, I went down 2. In order to get from negative 1 to 5, I went up 6. So I use that same value here. I'm going to have negative 3 minus 2, comma, negative 4 plus 6. That's going to give me my answers. Negative 3 minus 2. Remember, a negative minus more is going to get you a bigger negative. So negative 5, negative 4 plus 6, I get 2. And so there is my rectangle right there. Yay, everybody's happy. There's my right angle. Okay, and you can check your slopes to make sure you're doing it correctly. And that is one thing. If you're not sure, check your slopes. If it's not perpendicular lines, then it's not a rectangle. Okay? Number 15, not going to waste my time with. They are simply asking, hey, what value of x would make this a rectangle? Keep in mind, if it's a rectangle, all the corners are 90 degrees. So they gave us this value was in one of the corners of the shape. And so you would simply set that equal to 90 to make it a right triangle, or right angle, and then solve for x, okay? So subtract 15 divided by 5, too easy. 16, same thing, too easy. I'm not going to work it out. This is not algebra 1. All you're going to do is set them equal to each other. Diagonals need to be equal to each other, so you set them equal to each other. 17, almost too easy. I think it's interesting these last three come out pretty straightforward. They ask, hey, what could you do to a gate to make sure that it is square or to make sure that it is a rectangle, all right? Remember the square term I talked about in construction is when you're making sure that you have 90-degree angles in the corners, and they simply measure the diagonals, okay? So she would take her gate, she would run a tape measure diagonally, run it the other direction diagonally. As long as she gets the same value, her gate is a true rectangle, all right? Hopefully that was pretty good for you guys. I will see you at 16.3.